Hey, let's look at energy and chemical reactions study questions. We're just going to go over a few of the problems here, and we're going to start with 11. So 11 says, using the following thermochemical data, calculate the molar heat of combustion, which is represented as delta H naught with the subscript of combustion, of methane, which is CH4. So here we have our different equations with the individual delta H's for each of the reactions. And we need to basically make these add up to the combustion of methane by using Hess's law. And so we're going to go ahead and work this out on paper here. So I know that combustion results in the release of carbon dioxide and water. And so I'm going to rearrange these equations so that I have methane, CH4 breaking down with oxygen probably to form CO2 and water. So it's going to be some equation that looks like this. So I'm going to keep that in mind as I work through this. So the only equation here that has methane in it is the first one. So I'm going to go ahead and write that one out. So I have 2CH4 plus 3O2 reacts to form 2CO plus 4H2O. I'm going to make a column over here for delta H's. And so for this one, it's negative 1215 kilojoules. So next, I know that I need to cancel out CO, carbon monoxide, and the only equation I have that has CO in it is the second one, but I notice CO is on the right-hand side, and so I need to flip this equation. So I'm going to flip it, and then at the same time I'm going to flip this, the sign of the delta H. So that's going to be 2CO reacts to form 2 carbons and oxygen. So right away I can see, okay, 2 COs are going to cancel out there. Nice. Now I need to get rid of this carbon. I can also see that these oxygens are going to cancel out, but we can go ahead and do that later. So let's get rid of this carbon. Oh, first I'm going to write down 221 kilojoules. Okay, next let's write the last equation. So I have carbon plus oxygen reacts to form carbon dioxide. And I have negative 394 kilojoules. So I'm going to go through and cancel everything out and make sure that it all balances out. So here I notice I have 1 carbon here and 2 carbons here. I need to get 2 of these carbons to cancel. So I'm going to multiply this entire equation by 2 and the delta H by 2. So let's just add 2 in front of everything, and then we'll multiply this by 2 as well. Okay, let's see what happens. So my 2 carbons cancel out. Let's see, over here I have 5 oxygens. Only one of them cancels out though, so I'm going to get rid of that 2. So I'm left with 1. And what am I left with? I'm left with 2 methanes, 4 oxygens, 2 carbon dioxides, and 4 waters. Alright, let's add it all up. 2CH4 plus 4O2 reacts to form 2CO2 plus 4H2O. Let's see, all of my elements balance out. My chemical equation is balanced. Let's go ahead and add this up. When I add this up, I get 1782 kilojoules. But my answer needs to be, for delta H naught of combustion, it needs to be in kilojoules per mole. And here I notice this is kilojoules for 2 moles of methane. So all I need to do is divide this entire thing by 2, right? And my final equation is CH4 plus 2 O2s reacts to form CO2 plus 2 H2Os. And my final answer is, and that was negative 891 kilojoules per mole of methane. And that's my final answer. So that was number 11. Oops, there you go.